This is UC Davis Live. I'm Satirius Johnson. With wildfire season well underway in the Western US, attention is again turning to the role of forest management in causing or mitigating wildfires. How much of the severity and size of recent fires is due to management practices? How can we change forest management to mitigate the impact of fires? And what happens to a forest in the months and years after fire has passed? Joining us to discuss these and other questions are two UC Davis experts. Malcolm North is a forest ecologist with the USDA Forest Service's Pacific Southwest region and an adjunct professor at UC Davis. His research interests are in how disturbances after forest structure with far-reaching consequences for the ecosystem. And Andrew Latimer is a professor of plant sciences at UC Davis. He studies how plant populations and communities respond to change, including sudden major disturbances such as fire and drought, as well as more gradual changes in climate. Welcome to you both.
Thank you for having me.
Yeah, good to be here. Thanks.
So as a reminder, if you're watching us live, we are taking your questions. Just leave them in the comments section and we'll work in as many as we can. Andrew, let's start with you. The past few years have seen some of the worst fires in California's modern history. What are the drivers behind that?
Yeah, okay. Well, it's been hard to miss, right? That we've had the two of our biggest years in history, with the biggest in 2020. And the biggest, there's really a couple of big drivers of it. The biggest one is climate, the drying of the ecosystems. Droughts and really dry years produce really dry fuels. And the number one driver, this kind of spans all kinds of research people have done looking at fires across the whole Western US and then down to individual particular fires and their behavior. And then, people actually building models to predict the dynamics of a fire spreading. One of the really crucial variables is how dry is the fuel. If there's more moisture in the fuel, just like starting a fire in your fireplace, right? If it's water in it, it's slower to get going. But with drier, hotter weather, even just higher temperatures dries more of the moisture out of the fuels more quickly and produces this more continuous opportunities for fire to spread. And I don't want to also, that's not the only factor. The other big driver is just the buildup of fuels in a lot of ecosystems, and particularly forest ecosystems over the past century, which also provides, more energy when a fire ignites it, and then also more continuous, kind of a longer runway for the fire to run continuously through.
Right. So let's talk about that. How big a factor is the way forests are managed for fire risk? You talk about the buildup of fuel. Is the way we practice forest management right now a contributing factor, a major contributing factor to that?
Well, yeah. One of the things we kind of keep in mind is that what fires are burning, at least in the backcountry, and for most of the things that wildfires are burning are really plants and pieces of plants and the dead parts of plants that have already fallen off. And so what plants are growing and how big they are and how, where they're located, how closely packed they are, depends a lot on how we manage them, because a lot of these forest areas that are burning have at some point been logged or multiple times, sometimes managed for forestry, often replanted. So actually the composition, the size of the trees, the spacing of the trees we've influenced this, and I think Malcolm could actually speak even better to this than I can. But the one other thing I'd want to say is the big thing, I think folks are really familiar with this idea now, but that fire suppression has gone hand in hand with modern forestry practices in the West and in California in particular, at least since the beginning of the 20th century. And that's really been, caused this major shift in both the structure of forests and how much fuel is around. So that history of keeping fire out is now encouraging fire to come back.
Mm-hmm. Malcolm?
Yeah, I think Andrew raises a lot of good points. One thing to always keep in mind about California is fire is inevitable. We are a pyrogenic state. And so anytime we put a fire out, we may have good reasons for doing it when it's threatening homes or burning uncharacteristically, but it does kick the can down the road. You're going to get that fire again later, and you're likely to get it when you have more fuel around because trees grow and deposit more fuel, as do other plants. as well as the fact that you have imposed a selective pressure on the fire. So the nature of the fire you're seeing are the fires that occur when you have really high winds, very high temperatures, low humidity. And so what we're seeing is not the full range of fire. We're seeing the fires that escape suppression efforts. And so these are the ones that have burned 1 million acres in one fire in 2020. They're really extreme events. And it's not the type of fire that the forest in particular needs to keep it healthy. It's a type of fire which actually can kill most of the overstory trees and is very detrimental to the system.
Mm-hmm. You mentioned forest structure. I was wondering if you could just explain to us what forest structure means, and then also, does forest structure affect how fast fires spread?
Yeah, very much so. When we think about fire, there are 3 main types of fuels. There's the surface fuel load. There's what we call ladder fuels, which are literally kind of intermediate sized trees that allow the fire to move or ladder from the ground up into the overstory. And then the crown fuels, which is literally the green part of the tree, the foliage that's up high. And the thing that creates problem fires that has the biggest impact on how severe the fire burns, it's somewhat counterintuitive. You think it would be the green foliage part because that's where the fire is burning and jumping between the crowns. But what you need to be able to have that fire burn in the crowns is a lot of radiant convective heat from the surface fuels. And so about 60 to 70% of what drives extreme fires is how much stuff you have on the forest floor. Mm-hmm. And so that's really often the thing which matters most. And the thing to keep in mind with that is, if you think about it, there isn't a lot of commercial potential for removing that stuff. One of the things that we're always caught kind of between a rock and a hard place on this is that to be able to treat a forest and reduce the fuel loads in it, you often need to cut some intermediate sized trees to pay for the treatment to happen. But, if we circle back to these fuel loads, the real problem in the forest is the stuff, all the branches, the twigs, the litter, which is on the forest floor. And so it becomes difficult sometimes to be able to find the money to be able to treat the forest to reduce the intensity of fire. And that's where the whole structure issue comes into play.
Mm-hmm. Are you talking about, private landowners? Or are you talking about government-owned land?
Both, but particularly in much of the West, the Forest Service in particular owns about 70% of the public land. And so it's a big player. And to be able to do these type of treatments, to put it bluntly, most of the money that the Forest Service has gotten since about 2020, over 50% of it goes into fire suppression. That doesn't leave much money left to be able to get out in front of the problem by going into the forest before it burns and reducing the fuel loads. Because again, that costs money. That's expensive to do. So it's very difficult to get it done.
Right. So just shifting the money from fire suppression to this better practice of forest management, that's not a realistic possibility, because you still have to stay ahead of the fire that's burning today.
Yeah, a lot of the focus has been, kind of what we call triage, ending up going in and treating the forest after it's burned up, salvage logging, trying to rehabilitate the thing. The one thing I would say that has changed is about 2 years ago, they changed the way they finance fire. So it's treated now like floods or other big events and kept in a separate pot of money. So when you spend money on fire suppression, it doesn't diminish the budget of agencies like the Forest Service the way it used to in the past. And particularly with the infrastructure bill this last year, as well as the carbon credit tax in California, we're actually doing fairly well. We have the money to be able to really attack this problem. And we just have to figure out now how to get up to the right pace and scale to really impact fire, because we have not been able to treat enough of the forest historically to really have any impact on what happens when it burns.
Mm. Again, if you're watching us live, we are taking your questions. Just leave them in the comments section and we'll work in as many as we can. Andrew, what happens to a forest after a fire? I mean, do forests recover differently now than they would have before European settlement?
Yeah, that's a great question. And often you go to one of these areas that's just experienced a large and intense fire, and it can look pretty it can have a sort of emotional impact on you, especially if you're not used to seeing this. Or even for me, going out, I've been into a lot of burned areas. Some of the fires in 2020, kind of looking horizon to horizon, it's pretty much mostly ash. Um, but there is a fair amount of resilience in the system, and it depends on a lot of it. I mean, the number one factor really for how quickly and how well the forests come back is how many of the adult trees survive the fire. So if you got these areas where most, or essentially all of the adult trees have been killed, as has happened in large areas, at least since the Rim fire in 2013, in a number of large fires, and that really, the problem is it kills the trees, but the trees are the seed source, and the seed, they're the single seed supply for most of those conifer species. And so if you remove that from a large enough area, there aren't enough seeds coming in, and they can't go far enough to reach the centers of these large, severely burned areas. One of the kind of, on the plus side, if you go to the parts of the landscape where you get more of a mosaic of some greener and partly burned areas together with some high intensity patches, those can actually be pretty resilient because the surviving trees can dump a lot of seeds in. Then there's a lot of light, and there's less competition for the nutrients and water that are available in the soil. So trees can actually grow pretty quickly if they get established fast after a fire. And one thing I just wanted to, it seems it's kind of like an obscure plant fact, but it's actually really crucial to understanding why this happens, is that these conifer, are really familiar Sierra conifer tree species just don't have seed banks stored in the soil, and they also don't bank a lot of seeds stored in cones. So if the adults are killed, and that kills the seed supply. Mm-hmm. There are species of trees and plants that have plenty of seeds stored, like the shrubs in the ecosystem often have a really deep seed bank. And so in areas where tree seeds aren't available, what you see instead is often a really strong shrub response. Instead, so it'll convert at least temporarily over to a shrub-dominated system.
Right. Has development played a factor in this at all, or is it just? I mean, what has anything changed over the past, say, 100 or so years, 150 years?
Yeah, absolutely. Yeah, I mean, that's the big question. I mean, stepping way back, so what's changed since 150 years ago? I mean, a lot has changed, right? So the indigenous practices of actually working with fire a lot and using it to clear out understories and basically control the intensity of fires by keeping those surface fuel loads low. So indigenous communities were so there's a fair amount of lightning setting fires. And in addition, indigenous, tribal communities were setting fires fairly frequently to keep the surface fuels low. And so even when a fire came through, almost all the adult trees would survive the fire, plenty of seeds coming in. So really what's changed is suppressing fire and cutting some of those big trees down has really changed the structure of the forest, because when you remove fire, suddenly actually a lot more trees can grow and more quickly, and very quickly it develops into a dense sort of a thicket of trees that then carries fire really differently.
Right. So, but I guess in the modern era, we have this concept of the prescribed burn.
Yes.
Right. But we've moved away from that. Is it all just because of money?
No, it isn't all because of money. In fact, I think, Malcolm's point right now, money isn't the primary impediment. I mean, you could fund prescribed fire more for sure, but the biggest barriers, the state really has a commitment to actually ramp up its prescribed fire program by at least 10 times. And they're having trouble doing it. And the reasons are partly because if you get a really dry summer like last year, then there's risk of setting fire. And the window for setting a safe prescribed fire shrinks when it's really dry. And then second, there's always air quality issues as well. So if air quality is bad, generally you're not allowed to light a prescribed fire and contribute more particulate matter and ozone to the atmosphere.
So it kind of sounds like you're between a rock and a hard place here. I mean, what's the outlook? I mean, what can be done?
Well, it's a good question. I mean, there's a lot of momentum to try to change the constraints on burning, because it's clear that fire is going to have to play a big part in actually being able to deal with the fuels problem in the forest. Particularly, there's a substantial part of these landscapes that are pretty remote or in wilderness areas. And so you don't have the ability to use chainsaws and mechanically reduce the fuels. You're going to have to work with fire. And so one of the things the Forest Service is starting to do is to create these zones in remote areas. This is something the Park Service has been doing for quite a while. In fact, California, we were one of the first states in the country to start doing this back in the 60s, where if you get a lightning ignition in one of these areas, it's fairly remote, there's no homes nearby. Under the right kind of conditions, they will let it burn. And at present, that's probably the biggest use of fire that we have. Trying to change the restrictions on prescribed fire when we light the fire intentionally. There are several roadblocks to doing that. And I think agencies and many of the landowners are trying to systematically address some of these things and remove them, but it is a slow process. So either use of fire is tricky. And of course, there's a lot of lawyers in this country who are, ready in case something goes wrong to make sure that, there's reparations done through the courts to resolve some of these financial problems as well.
Right.
So, Terry,
please go ahead.
I had one thing on this. I think on one hand, it's use of prescribed fire or managed wildfire is, has been a big challenge. On the other hand, I would also say this is one of the areas that I feel really optimistic about and has really changed. If you look just back 10 years, the Forest Service was not where it is now. It's moved forward a lot on being willing to use managed wildfire in the backcountry, and Malcolm's been part of the drivers for that. And the other thing is that there's a really kind of a groundswell now of local organization by mainly private landowners to bring fire back onto their lands. There's some really great work done. For example, Lenya Quinn Davidson at UCANR is doing some great work organizing prescribed fire councils, which are groups of local people who bring fire back onto their land and kind of take control over the fuels. And there's also some really, I think, encouraging initiatives with collaborations between the government and private landowners and government and tribes to bring back more traditional fire use.
Interesting.
So there's some good trends. Yeah.
Yeah.
It needs to grow a lot, but there's some good things happening.
That's good to hear. Lisa, who's watching on Facebook, asked, she has two questions. The first one is, when burned areas are restored, are the same species being planted? Are there better species that are better adapted for a warming climate?
That's a good question. Yeah, I mean, most of the time, the same or very similar species are being planted. One of the things we always have to keep in mind is when we go into a forest, like let's say in the Sierra Nevadas, there's a lot more of fire sensitive species that are also shade tolerant. And particularly here, we're talking about white fir and incense cedar. We know from a lot of studies that those species made up maybe 20 or 30% of the forest before we started suppressing fires. But now when you walk into most of these forests, they're about 60 to 70% of the stems that are out there. So actually one of the intentions when after a forest burns is to try to make sure that at least in terms of planting, that we plant more pine, because pine is much better at resisting fire. And so we're trying to shift the species composition back to a more fire resistant composition. And that is one of the intentions that is an effort after these fires to restore forests and restore the right composition of the forest to the system.
You say it's an intention. Does that mean it's a policy or it's aspiration?
It's both. It's very clear that there's a real need to do it. Understandably, some people are worried that you're going to end up planting like wall-to-wall pine trees, and these forests have always been a mix of species, and so you still want to have some of that fir, you want to have some of that cedar, you want to have a range of systems. Frankly, the other thing that kills trees in these systems are bark beetles that come in after drought. And the interesting thing about bark beetles is they're very trees or species specific. So when you get a bark beetle outbreak, it will only kill the pine tree or the fir tree that beetle is associated with.
Wow, you
so
just can't win.
Yeah. So like, what you want to do with any type of thing, you want to diversify the species, so not all your eggs are in one basket, and
Right.
That's definitely the intention after these fires when areas are replanted, is to have a range of species.
Right. Her other question is it possible to do mechanical clearing in the wilderness? Can our old lumber towns be put back into use?
Wilderness, well, at least on the federal level, and most of the time, even when the state designates wilderness, mechanical tools are not allowed in there. And so you don't have that option. The only exception to that is if you have dead trees along roadways or campgrounds. Those are called hazard trees, and those are removed. And actually, the Park Service has done the same thing. They remove hazard trees as well. But otherwise, in wilderness areas, no, you cannot use mechanical means.
So I guess the begs the question, why not? And then should that rule be reconsidered, maybe?
Andrew, you want to do that one?
Oh, sure. Yeah. Well, I mean, what one reason why it's I see it as not a huge problem that we can't mechanically thin in wilderness areas is that well, this is not always true, but many of them are actually in these kind of areas that Malcolm talked about before, that are pretty far from built up areas and where managed wildfire is often used. So like the best examples are places in Yosemite, or the longest standing examples are in Yosemite and Sequoia Kings Canyon National Park, where lightning ignitions have often been let to burn for the past 50 years or so. And it's developed some really interesting effects and kind of brought those forests back to closer to, I guess, a healthy and pre-settlement situation. And so there's a lot of the other factor, I think, is a lot of the wilderness areas are higher elevation areas that don't actually have as much of a problem with fuel buildup. Yeah, and they just don't pose as much of a risk of fires spreading through those areas to people. That said, I mean, there are certainly cases where there are overgrown wilderness areas that would be difficult to use managed wildfire in, and so then, yeah, you're kind of up against a rock and a hard place. And
yeah,
I think it's a fairly low priority. There's so many places that we could use mechanical thinning and that are outside wilderness areas that, maybe someday we'll get to the point where we've got that all under control and we can think about doing it in wilderness.
Right.
One thing that Andrew's also kind of alluded to is that there's a perspective, particularly just in the last 10 years or so, about, well, let's try to use those tools so they complement each other. And so there's a lot of focus now on, well, if we can't thin in wilderness areas or some places that are really steep ground, let's strategically put the thinning places so that we can use them as anchors and spread fire between those anchors with prescribed burns or managed wildfire, so that we connect and kind of knit together the landscape. Because frankly, it's a complicated issue in these lands because there's a lot of restrictions on them. And so we really want to use every tool that we possibly can. And I think there's a real need to increase the level of thinning, but also make sure that the thinning is put in the right place so that you can actually start building a larger fuels reduced area in the landscape by connecting it with fire.
Mm-hmm. We have a question from Amy, who's our MA for watching on Facebook. This might be more of an air quality question, I don't know, but she asks, why must the classroom doors stay open with the AC on and the smoke from the fire permeating the air?
Huh.
Ooh,
that might be more of an air quality question than than a forest and wildfire question, but
That's, yeah. Well, I feel like we've really, I'm speaking of kind of being between two different constraints, like with COVID and wildfire smoke, we were in a really awful situation. I'm not sure what the best solution is.
right. Okay. So, I mean, so, if these big fires keep breaking out, does that eventually push the system back to the state before we started practicing fire suppression? Like, will we just kind of naturally get there?
When we have the right kind of fire, yes. Most of the Western states and most of the forests in California that's mid to low elevation needs a frequent surface fire. But when the fire burns too intensely, as Andrew was mentioning earlier, you kill the overstory trees, and then you end up in kind of this big hole that's hard to get out of because you don't have the seed source reestablishing the forest. You've removed the forest's ability to control the microclimate. There's no more shading anymore. A lot of the way that the forest recovers is having some green trees in there. And that becomes more and more of a problem as the fire severity increases and as you kill more and more of the overstory trees. And in that case, the fire is no longer being beneficial. It's actually starting to push the forest away from actually being a forest. And we've seen this in many places where we actually have type conversion going on in some of the drier, lower elevation places that are switching to chaparral or shrub communities.
Okay. And before we go, to help sum up, like what are 2 or 3 things we should be doing or could be doing better right now to mitigate the wildfire risk?
I guess I would say one thing that we haven't really touched on, but California and much of the West, very large, diverse area, and forests are a big part of the problem. But we actually have a different fire regime in Southern California and in the oak chaparral areas, in which surprisingly we have too much fire. And so it's the flip side of it. And climate is often the real driver in that system. There's a lot of the fingerprints of climate change extending the season, the length of the fire season, and creating more problems. And in those cases, simply reducing the fuel loads doesn't get you very much because the shrubs and the chaparral regrow quite quickly. So there's a different suite of solutions and problems to that, much of it having to do with zoning and hardening homes more. So the forest system, although it generates a lot of our focus and is a huge concern, it's only half of the problem. And in forests, a lot of the difficulty has resulted from management that has tried to put out all fire. But in the chaparral coastal communities, we actually have too much fire. So it's just a point I wanted to make is that there's not one size that fits all. It's kind of a more complex problem.
Mm-hmm. And when you mean too much fire, you mean too much uncontrolled wildfire?
Yeah, well, fire actually happening too frequently. I mean, one thing you can find quite a bit of this in Southern California is the chaparral and the oak woodlands will used to burn about once every 80 to 100 years in the past. And we have many places now that have burned every 10 years. And they don't come back even as chaparral or shrub communities. They come back as the exotic European grasses that have been introduced into the country. And so you really get a strong type conversion away from what those communities were for many, many eons before we had too much fire in the system. Mm-hmm, mm-hmm. So it's unusual to think about because the forest is really lacking fire. Most of the forest actually used to burn every 10 to 20 years, and many places haven't burned for over 100 years now. But the chaparral communities and the oak woodlands actually have too much fire, too frequent fire.
Mm-hmm. So. Andrew?
Yeah, well, a couple of things I would add. I totally agree with that. I think there is a really good opportunity now and need for more treatment, mechanical and prescribed fire and wildfire use, especially with the treatments being around places that really need to be well defended, places where people live, places where maybe there's endangered species, but mainly around neighborhoods. And so there is, I think, the will and the money to do that now. It's accelerating, and that should continue. And I think, one thing that connects to actually is that there's a kind of a workforce shortage as well for these kind of activities. And the state is starting to put money into programs to like certificate programs and other kind of community college type programs that hopefully can be a pipeline for people to get into these kind of jobs. And the other thing I would mention, so there's like the immediate, I think, kind of actions that we can take to protect communities better. And then there's kind of the bigger, as Malcolm alluded to, I mean, anything we can do to reduce emissions and keep climate change from going too hot will be the really important thing over the long run.
Mm-hmm. We have a couple questions from viewers I'd like to get in before we go. Grace from YouTube is asking, earlier you mentioned litigation and liability. Just out of curiosity, based on precedent from cases in the past, who would be held liable for damages for a prescribed fire?
Oh, it's a great question. The actual fire boss or the fire manager can be held liable for fire that escapes either the bounds of the area that they put into or that can burn into homes. And one of the things that California is looking at is the one part of the country that actually puts a lot of fire out on the landscape is the Southeast, particularly Florida and some of the other adjacent states, Georgia and so on. They have actually changed their liability rules so that if you follow a checklist and you make sure that you're very careful about setting the fire, the burn boss is not held liable or responsible as long as they were very careful about the fire when they lit it. And so there is some precedence. There's some areas where we could look to modify the way liability law is in the state of California to encourage more active use of fire.
Mm-hmm. And Will from YouTube says, tree mitigation for transportation projects typically include tree replanting. What are your thoughts on mitigating tree removal with proper forest management instead of planting trees?
Go ahead, Andrew.
Well, my only thought there is depending on the context, there's a lot of places where the tree density is just too high. So, I think when replanting, it's really important to keep an eye on what the ultimate density of that forest is going to be, and sort of thinking ahead to how it would burn if a fire got in there, and especially if it's next to a transportation corridor. That's really important. So there have been a lot of changes going on, right? Yeah, in how I think foresters are starting to think about the densities they're planting at. It's different if your goal is really to produce as much timber as possible per acre versus if you're trying to keep it resilient if there's a fire that goes through. Mainly, we just need lower. So that would be my thought is, yes, you can plant trees or you can retain some of the trees in the area, but probably keep the density lower.
Mm-hmm.
And I think one of the interesting things, I mean, Andrew's touched on exactly one of the key points is trying to keep the densities lower, particularly as the climate gets warmed and drier. But one thing that research has really uncovered just over the last 10 to 15 years is the spatial arrangement of the trees makes a big difference. And particularly what makes forests more resistant to fire and able to survive more intense fire is a kind of a group and gap type of pattern. So sometimes in the past, we've often planted trees on a regular spacing, a kind of gridded outline. And there's a more and more research suggesting that maybe we should think about trying to replicate this pattern that gives the forest more resilience to fire, which is kind of having some openings and some clumps of trees and mix it up some more.
Right. It seems like clumps of trees actually be a more natural distribution than a, kind of grid pattern.
Yeah, very much so. And it turns out the openings between the clumps does a lot to reduce the fire intensity. And so the fire kind of drops out of the tops of the crowns and moves back to burning on the surface of the forest floor. And that's exactly where we want the fire to be. So there's a real benefit to that.
Okay. Lisa from Facebook again is asking, can burned trees be monetized after a fire? Can Malcolm define type conversion? Does that mean the species mix changes over time?
Yeah, okay, so two good questions there. Burned trees can be monetized. The term for it is salvage logging. When you're going in and cutting dead trees, the tree is usually only worth about a third, maybe even a little bit less than that, of what it would be worth if it was still green, because the wood starts decaying and you have to get in there fairly quickly. But you can generate some revenue by cutting some of these dead trees, salvage logging. It has to be done pretty carefully because there's a lot of wildlife that depends on the dead trees as well. So there's trade-offs to be had there, but salvage logging particularly is something that some of the public agencies like the Forest Service have done a fair amount of after fires. The question about type conversion is when you're actually switching from not just one forest to another forest, but what we're seeing a lot of in California, where you're shifting from a forest into something different, which is often a shrub or chaparral type of system. And we have very aggressive shrubs in California, much of the West. As Andrew was alluding to, many of them have seed banks that persist for decades. And so you can burn off a forest and it'll come back in about 5 or 10 years, but it comes back as manzanita or ceanothus or one of the shrubs that's really aggressive. And that is type conversion. You're losing the forest to turn into a shrub community.
Interesting. Well, this has been a really fascinating conversation. I want to thank you both so much for, for your time and for sharing your important work.
That's been
Thank
fun.
you for having me. Yeah,
thanks.
Malcolm North is a forest ecologist with the USDA Forest Service's Pacific Southwest region and an adjunct professor at UC Davis. And Andrew Latimer is a professor of plant sciences at UC Davis. The show will be taking a summer hiatus, and we look forward to seeing you for the next season in the fall. If there are topics you'd like to see covered here in future episodes, please be sure to drop them in the comments section. Until next time, I'm Satirius Johnson, and this is UC Davis Live.